Welcome to Spring LIB.
So here we first need to know that the mass sub 1 is equal to 2 times the mass sub 2. Given this, we know that the initial kinetic energy of the first mass is equal to half of the initial kinetic energy of the second mass. We also know that 1/2 times mass sub 1, v sub 1 squared, equals 1/4 rather, m sub 2 v sub 2 squared. So if we have this, we can say that we can also create another relationship and say that the final kinetic energy equals the final kinetic energy of the first mass equals the final kinetic energy of the second mass. And then substituting for this, we have 1/2 times m sub 1 times v sub 1 plus 7 meters per second squared equals 1/2 m sub 2 v sub 2 plus 7 squared. So at this point, we can substitute in for this and say that 1/2 times 2 times mass sub 2 times velocity sub 1 squared would be equal to 1/4 mass sub 2 velocity sub 2 squared. The mass, of course, cancels out, and we have that 2 times the velocity of the first mass equals the velocity of the second mass. My apologies, just mass. And then let's substitute this relationship in for this equation here and say that 1/2, rather, let's get a new workbook. 1/2 times m sub 1/2 times 2m sub 2 times v sub 1 plus 7 squared equals 1/2 times m sub 2 times v sub 2 plus 7 squared. And so we can say that 2 times v sub 1 plus 7 squared equals v sub 2 plus 7 squared, given that all of this cancels out. And so we can say, well, that this cancels out. And so we can say that if we were to solve for this, we can say that 2 times v sub 1 plus 7 squared equals 2 times v sub 1 plus 7 squared. And then solving for v sub 1, it's simply going to be 4.95 meters per second. And then we know that v sub 2 is equaling 2 times v sub 1. So v sub 2 is simply equal to 9.90 meters per second. So these would be our two final answers. That is the end of the solution. Thank you for watching.